Hello. Today we are going to do percentages, basics of percentages, how to calculate percentage of any number, how to calculate percentage change, successive percentage change, and various tricks. So let us start with the very basic definition of percentage. What is percentage? When I say percent, percent means comparing any number with 100%. So when I write down x percent, it is x divided by 100. So I can convert any percentage into ratio. And this is very useful while calculating percentage of any number. So we must know some standard percentage to ratio conversions. Let us start. 100%. 100% in ratio would be 100 by 100. That is 1. 50%. 50% in ratio would be 50 by 100, that is half. 25%, 1 by 2. In this way, we have to remember some very basic percentage to ratio conversions. I'm just writing it down so that you can refer to it. So we must be well aware of these standard percentages and the ratio form. And then we are ready to start with the calculation part. Let us understand what is percentage change. Suppose I have 1000 rupees with me and I increase it by 20%. 20% of 1000 is 200. So if I'm increasing it, my final amount would be 1200 rupees. Now, what if I again increase this amount by 30%? So my new initial amount would be 1200 rupees, which is now increased by 30%. What is 30% of 1200? It is 360. Now, when I'm increasing it by 360, my final value is 1560 rupees. Now, if you observe, I had 1000 rupees earlier. I increased it by 20% initially, got 1200. I then again increased it by 30% and final value was 1560. What happened over here? I performed successive percentage changes or successive percentage increments. First by 20% and then by 30%. If you observe, my initial to final value has changed by 560 rupees. That 560 rupees is 56% of 1000. So instead of saying it like this, increase an amount by 20% and then again by 30% successively, I could have directly said increase the amount by 56%. But mind you, 30 and 20, it is not 50, it is 56. Why this change? So this is how successive percentage works, right? When I break it down. But not every time I'm going to use it. So what I'm going to do is, I'm going to use a very simple formula over here, which is obviously derived from this successive percentage change formula. Successive percentage change formula. A plus B plus A multiplied by B divided by 100, the whole percentage. How does it work? So, as I said, I increased the amount by 20% and then again by 30%. Whenever I say increment, the value has to be positive. When I say decrement, the value has to be negative. So in our case, the two percentages were 20 and 30, both were increments, so plus 20 and plus 30. My value of A would be 20, B would be 30. Let us substitute these values in this equation and check if we get it. Let us substitute these values in this equation and check if we are getting 1560. Let us substitute these values in this equation and check if we are getting 56% at the final print. A plus B plus A into B divided by 100. 20 plus 30 is 50. I have 50. 20 into 30 divided by 100 is 6. Final value is 56%. It is a positive percentage, which means it is an increment, and hence I can say that I could have directly written 56% instead of two successive changes of 20%, 30%. Let us take another example where I'm going to use increment and decrement both for the same amount. Now here I have 1000 rupees with me again, but I'm going to increase it first by 20% and then decrease it by 30%. Let's solve it in conventional manner and then we'll check with the formula. So conventionally it would be when 20% is increased, my amount becomes 1200. Now I have to decrease it by 30%. 30% of 1200 was 360 rupees. And if I remove 360 from 1200, I'm going to get 840 rupees. So if you observe, my initial value was 1000 and my final value was 840 rupees. The change over here was of 160 rupees. And what is that 160? It was decrement. So can I say that 160, which is 16% of 1000 rupees, was my actual percentage change, 16% decrement. So the final value was minus 16%. This is what I can comprehend over here. Let us check using this formula. A would be 20, but then B would be minus 30 because it is decrement. So 20 minus 30 plus 20 into minus 30 divided by, this is minus 10, 2 into 3 is 6, and it will be a minus 6, 0 gets cancelled out, minus 16%, clearly 16% decrement, and that is my final value. So this is how you use this formula. Let us check how to use it when there are multiple successive changes. So I have a case wherein I have to increase an amount by 10%, then again successively decrease it by 20%, then again successively increase it by 30%. So this successive change has 3%. So this successive change has 3% values. What I'm going to do is to utilize that formula, I will take 2 at a time. So let us first solve 10 and 20, and then whatever value that we get, we are going to solve it with 30. Mind you, you can take any 2% at one time. You can take 10 and 30 also, that's absolutely fine. 20 and 30, that is also absolutely fine. Your answer would not change. We will learn how and why later on. So 10 minus 20 plus 10 into minus 20 divided by 100. This is minus 10. This is minus 2. Gives me minus 12%. So this is my change with only 10% increment and 20% decrement. I'm going to use this with 30 to calculate my final answer. So I have A as minus 12, B as 30. My final change would be, so 30 minus 12, which is 18, and this is minus of 3.6. My final value would be 14.4%. Since this is a positive value, obviously it is 14.4% increment. And this is how you can use the formula for n number of successive percentage changes, taking 2 at a time. It kind of looks like a binary tree. When I say that I have to change an amount by some percentage, let's say I have 1000 rupees and I have to increase it by 20%. What I mean is, if I have 1000 rupees with me, I have to increase it by 20%. Now this increment, can I say this 1000 rupees? This 1000 rupees is my 100% of my value, and I have to increase it by 20%. So my final value should be 120% of my initial value. This is the multiplying factor if I convert it into its ratio form or decimal form, which is 120 by 100. In ratio form it would be 6 by 5, and in decimal form it would be 1.2. So when I say that increase an amount by 20%, what I mean is just multiply that amount by 6 by 5 or 1.2, and that is your multiplying factor. and you'll get your final value. So if I multiply 1000 with 1.2, I'm getting 1200, and that is the answer, right? Because 20% of 1000 is 200, add it, you get 1200. Even if you multiply it with 6 by 5, the answer will be same. So this is the multiplying factor. It is very important. And likewise, if I say that increase it successively by 20% and then 30%, keep in mind that now my initial value would be 1200, and if I'm increasing this amount by 30%, I will again use this concept of 100% plus 30%, which is 130%, and in ratio format or in decimal format, it will be 1.3. So this value will be multiplied by 1.3, right? So my final value would be 1200 multiplied by 1.3. Now, if you observe, if I have to compare it with 1000 rupees, a successive percentage change of 20% and 30% can be written as 1000 multiplied by 1.2 multiplied by 1.3. So as you can see, the multiplying factor keeps getting, so as you can see, I'm attaching the multiplying factor every time I'm changing it, right? If it is obviously increment, it is 1 point something. If it was decrement, it would have been 0 point something. Why? Because if I say decrease it by 20%, it would have been 100% minus 20%, which is 80%. So this is decrement, right? So decrement is 80%, which is in ratio format 0.8. So the multiplying factor is very important while calculating the percentage change. Increase, it will be 1 point something. Decrease, it will be 0 point something. I hope this is clear. So if you have n number of successive changes, increase in amount by 10%, 20%, 30%, and likewise, you'll keep on multiplying it with 1.2, 1.3, 1.4. And in that, even if you have decrease it by 20% and then 30%, that multiplying factor will continue and it will multiply by 0.8 and 0.7 likewise. Let us take an example to elaborate. Suppose I have 10% increment, 20% decrement, 30% increment, 40% decrement, 50% increment. Now clearly I have 5 successive percentage changes, and applying it in that formula, I'll have to do multiple operations over here. Instead of that, what I can do is, I can just use the multiplying factor. If you remember, increment was 1 point something, decrement was 0 point something. 10% increment would be 110%, which is 1.1. So the multiplying factor would be 1.1. And since it is successive, multiplication sign is mandatory. Decrement by 20%, 0.8, right? Because it was 80%. And increase by 30, 1.3. And decrease by 40, 0.6. And increase by 50, 1.5. This is very easy. Now if you multiply this, you'll get the final percentage change. You'll get the final multiplying factor, which will give you the final percentage change. So it saves a lot of time, and especially for competitive examinations, it is very, very useful. Right? Let us see how to work with ratios. Here we have an increment of 14.28% and a decrement of 33.33%. I cannot use the successive change formula over here. I mean, I can use it, but if I use it, it will be time consuming. So I'm going to use the ratios. The concept of ratios, that's why it was very important, which I gave you at the very beginning. The concept of ratios was very important, that's why I gave you at the very beginning, right? Let's see. So 14.28. Keep in mind that 14.28 was 1 by 7 in ratio. 33.33 was 1 by 3 in ratio. So I have an amount and I have to increase it by 1 by 7 and then successively decrease it by 1 by 3. What will be the final percentage change? That is the question, right? Effective percentage change. Using it in the formula, worthless, time consuming. What I'm going to do is, since the denominator has 7 and 3 both, I'm going to assume a number which is a multiple of both 7 and 3. Let us assume that our initial number is 21. Right? So this is initial. Now, first step, increase it by 1 by 7. Increase it by 1 by 7. So 1/7 of 21. I have to add it because it increment. 27, 21. 1 by 7 of 21 is 3. Add 3 to this. My final value would be 24. Now decrease it by 1/3. So 1/3 of 24 is 8. Decrease 8. Remove 8. Our final value is 16. This is my initial. This is my final. Now, if you observe, my final value has decreased by how much? By 5 as compared to my initial. So my actual percentage change would be a decrement, so a minus sign of 5 over 21 multiplied by 100. And if you solve it, you'll get your final answer, which works around to be somewhere near 23.8% with a minus sign, obviously. I got this, and that too quickly. So, percentage offset, a very important concept. Let's learn it with the help of this example. A has 25% more money than B, then B has what percent less money as compared to A. Alright? So, their actual amount is not going to change, just the perspective is going to change, hence the value is also going to change, it is not 25%. Suppose B has 100 rupees. Then A would be having 125 rupees, clearly 25% more. Now the question is, how much does B have less as compared to A? So I can see that B has 25 less as compared to A. Since 25 less as compared to A, it has to be compared with the value of A. And if I do the math, this is 20%. So from 100 to 125, I had kind of multiplied it with 1.25, or can I say multiplied it with 5 by 4, right? That is 1.25. Just keep this in mind, right? 1.25 because 25% it was more. Because 25% in ratio is 1 by 4. And if I'm increasing an amount by 1 by 4, my final value would be 100% plus 25%, which is 5 by 4. So, if I multiply this number by 5 by 4, I'm going to get 125. By what number, by what ratio should I multiply 125 so as to get 100 back? I will have to multiply it with 4 by. If I multiply it with 4 by 5, I'm going to get 100 rupees back. Right? Now, what is this 4 by 5? Can I say the actual value, if it was 1, I have to reduce it by 1 by 5 to get 4 by 5? And what is 1 by 5 in ratio? It is 20%, which was our answer. Right? So, this is percentage offset. Let us relate these two and generalize it. This is the trick. So, if there is a change of 1 by x in the forward direction, if there is an increment of 1 by x in the forward direction where 1 by x is the ratio form of percentage. Ratio form of percentage. So if there is a 1 by x increment in the forward direction, the reverse direction has to be 1 upon x plus 1 directly. So if I say that an amount is increased by 25% to get back the original value, I should decrease it by 20% and done. This can also be extended. So if I decrease a value by 1 by x in the forward direction, I should increase the value by 1 minus, I should increase the value by 1 upon x minus 1 in the reverse direction. So both the cases have been taken care of, right? So if I decrease an amount by, let's say, 20% in the forward direction, the reverse has to be done, the reverse has to be 25% because 20% was 1 by 5, 25%. 1 by 5 minus 1 will be 1 by 4, that is 25%, and it has to be increased by 25% to get the previous value. So this is percentage offset, and here we conclude our basics of percentages. Please revise it This is very important before you solve any good percentage questions or top level percentage questions. This is a must. Thank you so much. Be with me.